Drought situation across the country may not be as good as you think, considering how historically wet the season was. Following up on former videos, we're going to talk about some of the record-setting precipitation we picked up over the winter season, what maybe led to that. Plus, we're going to be chatting about all that snow that's out in the northern plains. How can they be so dry soil there with all that snowfall? These are some of the questions that you asked in previous videos that I'll address in this one. And again, we're talking about the drought here. The drought, tremendous drought conditions plague the plains. That does continue. Meanwhile, others have seen some recovery. We'll talk about recovery in a moment, and you can guess where that is, mostly off to the west, but there still is a drought footprint there. As you look at this map fly in, this is the drought monitor released as of April 20th. The deepest red areas that you see from Nebraska through Kansas, Oklahoma, all the way down south into New Mexico and Texas, that's the exceptional drought region. That's where drought conditions are the worst. That's the highest rating for drought. And right now, problematic areas are mostly those central and southern plains without much of a light at the end of the tunnel just yet. But we have seen recovery, especially out to the west. Let's set the stage. This map is the water year. Our water year starts in October. So October through the end of March, I like to use big chunks of months, verified data that way. So through March, so 6 months, we have record-setting precipitation here out to the west, in pockets here in northern Wisconsin too. Those are the deepest green colors on the map. That's the record wettest on the period of record used for this, and that record, if you're wondering, started in 1895. This is PRISM data, great data. Then the wettest 10% years are in that next shade of green, and that covers a vast majority of the west, the southwest, some of the northern plains, upper Midwest, on down to the south. Very wet season so far. Wetter, I should say, very wet water year so far. But then on the other side of that coin, we have near normal to drier and driest 10%, and even record driest conditions around Pueblo, Colorado, Lamar, out towards Dodge City, so over Liberal and Garden City, stretching out toward Hayes, was record-setting dryness. Let's talk about the record highest snow equivalent. We've talked about the flooding potential in previous videos. Well, the flooding potential is so high for the west, obviously, so snowpack. So what I did here was there are snow-tell stations. Snow-tell are on the mountains, and they measure the amount of snow so that we have a gauge or at least a sense of what our water situation will be like. And so for this particular one, use snow-tell sites, and then I grabbed those that would just have 30 years of data. So I went from about 1,144 stations down to a few by eliminating, just getting that 30 years worth of data. I don't want a station that's only been around for 10 years. That doesn't really give me historic perspective. So at least 30 years, and then it went even further. I asked myself, let's filter that down to give me the top 3 snow water equivalents on record. And what we have here is the top. These blue dots indicate the record most snow water equivalent. So that's how much water is sitting in that snowfall. And each of these sites is in their record. And again, they all have at least 30 years of data. Some go to 60, 70 years of data. So out of 1,144 total stations, filtered that down to 133 that had their top 3 seasons. 133, that's notable. That's about 10% roughly speaking. 49 have had their top 1. And these are the 49 dots that you see on this map. And then another interesting question that somebody asked here on YouTube was, show me the duration. It felt like such a long winter. Is there data, Matt, to equate to? Was it really that long of a winter? Well, it's kind of hard to say. You could look at gray skies, overcast conditions. You could look at temperatures, and we will in a moment. I thought in this case, to me, what reflects winter is always seeing snow. So I went into the records and grabbed there are thousands. So I went into the records and grabbed thousands of stations that report daily snow depth, how much snow is sitting on the ground. Out of those thousands, I then went and said, I want to see at least an inch. I don't need a trace. I want to know that there's at least an inch of snow on the ground. How many consecutive days did these sites see at least 1 inch of snow on the ground? All of these red diamonds that you see on the map, and that's going to be 85 of them, 85 total stations out of thousands. Each one of these set their individual record for longest streaks for having at least 1 inch of snow on the ground. Now maybe in your mind you're thinking about, well, winter would be how snowy we were in total. Not snow days, but how snowy. So this graphic came up from Dennis Toddy in a webinar he did. Great resource he is. He's a wealth of knowledge. But snow records, and he compiled this list. Duluth had their snowiest season, 137.1 inches. Riverton, Wyoming. St. Cloud, Minnesota with their second. Minneapolis, third. Bismarck, Glasgow, Casper, winter, third snowiest winter with these associated snows. Remarkable. So yes, depending on where you are, very long winter, very snowy winter, and a historic one for many of us. But why are we not necessarily seeing this all translate into the drought situation? Soil moisture is shown here. And this particular product uses data that goes back to 1895. So we're relating what we have now compared to that more than 100-year database. We're historically wet out to the west in a lot of cases, as well as the upper Midwest. These deeper reds that we have, primarily over the plains, but also in the northern Rockies of Montana, these deeper reds, where that one is, this is the driest soil moisture on record since 1895 in these noted areas. But what about Nebraska, the Dakotas, Wyoming, Montana, sites that had a long winter or a snowy winter? What's going on there? That's a common question. The issue is for the northern areas, the ground froze with very little water in it last fall. With a frozen ground, sure, you can just pile that snow on there, leave that snow sitting there. It doesn't get into the soil. The soil is frozen. So until that soil thaws, then you can efficiently increase soil moisture. During the last couple of weeks, we saw that explosion of temperatures, really rapid warming trend, record highs in a lot of cases stretching from Nebraska to Colorado and northward. That rapid warm-up not only melted a lot of the snow off, but it also thawed a lot of the soil. So in some cases, we have been able to resaturate soil. The problem with that is, on the other side of the coin, is in that video I did about flooding potential. It melted so quickly we have flooding conditions. Flooding, yes, will help soil moisture, but the detriment is that it's flooding. So that's another situation across the north. And that's why that snowpack, historically so for the northern plains in some cases, isn't really translating into the drought monitor just yet. How big of a change have we had this drought season? Over the last 4 weeks, most of that change has happened Great Basin, out into California. Some hit and miss pockets in the Pacific Northwest have improved. Improved on this map are the greens. Yellows, however, yellows in Colorado, Kansas, down southward through Texas, East Coast down through Florida, into the north near Minnesota. That's where the drought has actually gotten worse. In some cases, it's wind. Been very windy dust storms for the central and southern plains. That's caused a lot of evaporation of the little soil moisture that's there. So that's part of the equation. The other side is we haven't really had a lot of precipitation, especially here. For the north, where we've seen that drought improvement, that's due to some snow melt. For northern Minnesota, we have the drought kind of growing because of those concerns of we lost the snow too quickly. The soil is still frozen. So we don't have a true picture of soil moisture that far north until it fully thaws out. So that was 4 weeks, 1 month. What about the last 3 months? And that's where we see notable improvements, especially west, northern plains, sections of Oklahoma. Oklahoma's been kind of interesting. Cut Oklahoma in half. Eastern half, the drought has improved greatly. Western half, however, we're still seeing drought conditions and they've grown. So we've had record wet conditions, right, for the water year out to the west, and that's improved the drought situation there. Other areas have been so dry that the drought does continue. Now, one thing that has helped, and I've kind of alluded to it, is the temperatures for the water year so far. Temperature percentile, October 22nd through March 23rd, again using full months, some historically cold numbers for the west, parts of Colorado, especially Wyoming, parts of Idaho, especially Nevada. Some of these areas had the record coldest winter. Then for the eastern U.S., remember where the drought got worse for the East Coast down through Florida? Record heat for the first 6 months of the water year for the East. Where are we headed as we go forward in time? Well, we've got drought growth expected in the yellow areas. So Washington, New Mexico, parts of Texas. The brown areas indicate where drought will remain. So we're going to keep the drought around for the central plains, the southern plains, parts of Nevada, California, Utah, despite all that snow, despite the wet pattern, still in drought. Soil moisture has improved greatly, but we're still way behind the 8 ball in terms of total precip over the last several years, even though we made some great ground here recently. For Nebraska on up to the north, those areas that are in drought may remain in drought with some minor improvements to the outskirts. So yes, we had historically wet numbers, historically cold to help supplement that moisture and keep it around, but the drought footprint is still very, very strong across the central and southern plains. How do we get from a La Nina pattern with drought into a new pattern that would eliminate this drought? It's going to take a very, very long time to do so. El Nino is a factor that may help this, especially next winter, and that's when we classically get a lot of water across the southern tier of the U.S. into those drought areas, but that's next winter. This is the El Nino forecast starting from right now, which is right here. Let's get into the summer, June, July, August, JJA. The percentage chance of having El Nino in place, the red bar, is above 70% at this point. As you go forward in time, that probability does increase. So the odds of El Nino kicking in this summer do increase. Note from previous videos, though, that's a forecast for the ocean, not how the atmosphere above will want to behave. So from a drought standpoint, we've got a problematic area, Kansas, down through Oklahoma, Texas, eastern New Mexico, eastern Colorado, parts of Nebraska, parts of the Dakotas still in drought, but we walked through that video there to show you where that may improve. But the problem for the drought areas does remain. The outlook is not promising for the growing season in those states, I'm afraid. With El Nino kicking in, though, that's opening the door to brighter conditions, wetter conditions, brighter metaphorically, wetter conditions as we get into next fall, next winter, and next spring. If you're wondering about the summer outlook with El Nino, check out this video. It breaks down what neutral years have done, what El Nino years have done,